Okay, we've taken care of some of the basics. What we want to proceed and do now, we want to look at what? At logic, at some simple applications of what? Applications of PLCs, where we can the knowledge that we've learned so far, where we can use it. Let's apply it a little bit with gates. So we're going to start with the simplest gate, which is the buffer gate. Let's go and get one software. So we click on the icon there in the taskbar. Okay, wherever you saved it, find your thing, and then now we obviously need a new file. So Control N or File New, or just click on the icon. That's straightforward. Now we want to do logic gates. So name logic gates, and then we want that to be buffer. I'll do the buffer and the not, because buffer and not, because they are really it's easy to move from the one to the other. All right, so what we'll do is I'll start with the buffer, then I'll progress to the not. Now all I want to do now is obviously make my screen a little bit more visible for you. So we've been doing this one forever. So now what we can do now is we can say function F1, or we can say there, hit on the what, on the icon there, or double click on the space and just type load, whichever you are comfortable with. Load, and we want that to be the very first gate, so therefore very first input, therefore this will be x0. Now there we have our x0, and then all we need now is our output. So I can also do the same thing, F7, function F7, one option. I can click on the icon, or I can simply type out. All right, and then I can say what output am I looking for? The first output, y0, and there we are. That is our buffer. Remember, the buffer is usually used as a what? As an in-between stage, as a handshaking stage. All right, so you have an output from one stage that is supposed to go and feed the input of the next stage, but somehow they're not compatible, right? The input characteristics of the next stage it does not necessarily match the output characteristics of the what, of the previous stage, but the voltages are fine. But other characteristics, from impedance to whatever else, to currents, whatever, it may not be the same. It might, so what you do, you then have a buffer that will have on the input side of the buffer, it will match the output of the previous stage, and on the output of the buffer, it will match the what, the input of the next stage. So basically it's a handshaking situation here. The in-between guy, the guy who makes two guys talk, all right, is the mediator. All right, the buffer is more or less like the mediator. Now, so the buffer should not change anything. It just takes from one and feeds to the next, just avoiding what call this clashes and incompatibility. All right, you try to make the two stages compatible. So now if you look, so the buffer, whatever comes through the input must go out to the output. So if the input is low, the output must be low. If the input goes high, the output must also go high. So obviously we've been doing this. This is where we started. If I now say, I don't even know if I have to simulate this, but maybe sometimes the proof of the pudding is in the taste. So we can say, let's go and say, is it sweet? Is it pudding, or is it, I don't want to say. Now, if we set this out, by the way, before I do that, I have to go and get out of debug mode. Let's put it online, all right? And then obviously now we need to run it, because it's on stop mode. It's on stop mode, so now we get out of it with the run mode, and then we say, okay, sharp, let's run. Now, as you can see, the input is low, the output is low. All right, now I'll go and set it high by saying set on, which is high. The moment that the input goes high, the output follows suit. All right, so this is our basic buffer gate. Take this time to see if you like, replay if you thought maybe I spoke a little bit too fast or a little bit too slow. You've got the option to, I don't know if you can increase the speed or something, but then make sure you understand this is our buffer gate. All right, then In the interim, please remember to like and subscribe to join the family so you get notifications when we hit you with the latest one. So you must be the first to know. So subscribe, and then also please comment there and tell us where you are so we know who we're talking to, where we're getting most of our support from, and if there's problems, you can actually highlight them also on the comment section there. It also helps with with the algorithm. Next time you're looking for us, it won't be a problem. Will be put on top of the list, right? So please assist in that regard. Let's go on and look at the next part. The next part is like I said, we are moving from one to the other. It's almost like we looked at the normally open input. Now we just change that input to normally closed. So all we do is, let me just double click on it and change that to LDI. If you don't know where to get these instructions from, if you don't know, you just go to the help window there. All right, let me first accept this. Okay, it's now normally closed. Just go to the help window there and you just say, if you go to the PL instruction there, you can get all these instructions there. What is LDI? Load load a contact, LD, LDI, and any. All these things are basically the instruction list is there and it's explained. You can just click on it for more information. You can just click on it and they'll explain that for you. So the more you do this, the better you get at it. So I don't think people should really worry too much. You will learn as we go. All right, you learn as we go. Now I'm also going to look at the instruction list at a later stage so people understand. Those who like more to work with the instruction list, now they will understand. Now if we look at this now, all right, we have all we did was change the input from what? We changed the input type from a normally open to a normally closed, and that had the effect of changing our buffer gate into a NOT gate. All right, our buffer gate into a NOT gate. Now what does it mean? Because this is already closed, as you can see, the line will therefore be closed because that's the only component there. So it means that if you put this on, power will go through straight away. You haven't done anything, you haven't engaged your input, and then your output will already be happy. But as long as you want that input to stay, you should not touch that input button there. You should not touch XO. You should not. That is where the name comes from. The NOT gate. You want an output, do not touch that input. If you don't want an output, touch that input there. Let's simulate and see if that's true. We don't do anything. As you can see, when we debug, because we wanted this good practice, but then now so people don't forget when they need to. Now we put it on run, and you can see he's saying I'm already letting power through. All right. So the moment you run, meaning you enable the circuit, the moment you run, you can see that yes, I wish to continue, and you can see that the moment I didn't do anything. All I did was run the circuit, but we looked at this already, and you can see that we have an output. So it means therefore, if I want that output to stay, I should not touch that input, which is where it gets the name from. All right. So this is our NOT gate. All right. If I am to put the two together, because now I want to believe that you saw how easy it was for the buffer. The input was normally open, but for the inverter, or remember our NOT gate is sometimes called the inverter. For the inverter or NOT gate, the input and the output are going to be opposite. Now you have for the inverter, the inputs and outputs are going to be opposite. If I have not engaged this input is on 0 in terms of digital levels. Name 0 means on. 0 means 1 unless we're describing negative logic. With positive logic, 0 means 1, and 1 means what? What did I say? It says 0 means 1. 0 means low and 1 means high. All right. Or 0 means inactive and 1 means active. All right. So now because this is not set on, it's on 0, yet the output is on 1. All right. When I set this on, when I send this to 1, that output goes to 0. All right. Because this is on, I've set it on, set on. You can see it's on, it's on now, and the output is off. But if I set it off, there you can see set off. When I set it off, and the output goes high. Alright, so this is basically the inverter. It inverts. Remember, it's a binary situation. If it's not a low, it's a high. If it's not a high, it's a low. Alright, so these two are opposite. Output and input are always going to be at opposite states. So this is your inverter, otherwise called the NOT gate. I hope you enjoyed that session. I hope I didn't become too tautological and too verbose for nothing and end up confusing the whole simple thing. This is a very simple concept. I don't think it's difficult. So if you like, please show it. There is a like button for you. Hit it. And then also remember, if you're not part of the family for some reason, you enjoyed too much, you didn't remember that you must belong to the family, hit that subscribe button as well, and comment, tell us where you are so we know where our people are. We'll meet again with the next case. There's a few more cases to look at, so our next session we'll look at the other case. Thank you.